Okay, so here we are, August 26, 2025. It is the fourth Tuesday of the month for the monthly Cosmobiology Institute research meeting. And this meeting is to help you with anything you're curious about in research, anything at all related to astrological research. Christopher and I are here to help guide us along the way. I have only one question so far. So we'll start with that. It's from Kai, and she's asking about statistical tests, when to use a chi-square versus z-test. And Christopher is really, um, outstanding in answering these kind of questions. I'm going to hand it over to Christopher to talk about chi-square, z-tests, and stuff like that.
Yeah, there are four tests that I think are often interchangeable when you're trying to compare two proportions to one another. And I'm thinking mainly of the case where you have a what we call a two by two contingency table. You're dealing with two categorical variables such as um, let's say we take gender and how people vote in an election, whether Republican or Democrat. So let's forget about independent third party candidates for the moment. Uh, so you can imagine a two by two table where, uh, let's see, one column might represent men, another column might represent women. And then if you look at the rows, one row could represent voting for the Democratic candidate, uh, another row for the Republican candidate.
Right, so I'm
And
putting this up here. So if we have male and female, this is actually a common kind of thing. Like um, sometimes this is American politics, women vote more Democratic than males, for example, is a kind of thing that sometimes is found. And um, so just to make this clear to everybody, if you want to know who's voting Republican, who's voting Democrat, and here we have a simple case of a two by two table, and as Christopher said, sometimes called a contingency table. And Christopher, I think you just you count up the number of people and you stick them in each of these four boxes, right?
right, the numbers which go in the four boxes they're all going to be counts. So number of men who voted Republican, number of women who voted Republican, number of men who voted Democrat, number of women who voted for the Democrat. And usually, uh, our categorical variables, we might call the top one gender, and let's see, this other one political party, something like that.
Yeah, so we're
And
gonna have some numbers in here, and then we can give a title to the variables. This can be called gender, and this could be called political party.
yeah,
I'll just put like that. Yeah. So this is the kind of statistic you use depends on the kind of data you've collected. So if you're comparing two sets of categories, um, well, you can take it from here, Christopher. So what kind of tests, what might we use for this?
well, if we use a chi-square test, which is, and this is kind of a classic example for that sort of thing, then what we're wondering is there any relationship between these two categorical variables? Uh, the political party preference here and gender. And in other words, are men and women voting pretty much the same way? Okay. And when we do the chi-square test, we call these the observed values. This is how people actually voted. And we also have to compute and if we were doing this all by hand, we would figure out the expected values. Uh, the values we would expect to have in each of these cells. And there's a kind of a simple way we get that. I don't want to belabor this point, but you find the totals for both columns and you find the totals for both rows, and you add your the totals you have at the bottom, the totals you have over here at the side, they should add up to the same grand total. Okay. So let's hear you adding everything up, Santino.
Yeah, assuming I can add, that's a big assumption. But but if I can add, so I've totaled up the Republicans, 936, the Democrats, they're 1,023, there are 984 males and there are 975 females. And so 936 plus 1023 should equal 984 plus 975.
Yeah, it should be 1,959
Okay.
for the grand total.
1,959.
Yeah. Now let's see. We had 936 for that first row total. And let's see if I divide that by 1,959, that comes out to about 48%.
Okay.
Just as a reference point, the way we find the expected values is if 48% of these people voted Republican, and if there's no interaction between the political party and gender, these two categorical variables, then if you've got 984 people who were male, you'd expect 48% of them to vote Republican. And if you got 975 females, you'd expect about 48% of them to vote Republican. And what we're doing, it kind of reduces to very simple formula. To get the expected value in that first cell for male Republicans, you just take the that column total, 84. Oops.
984.
Yeah, I lost my video and microphone for a minute. Let's see if I can get it back. Can you hear me?
Yeah, we hear you.
Yes.
Okay. Yeah. You take let's see, the column total for males times the row total for Republicans divided by your grand total. That gives you the expected value here. And that's just a shortcut way of saying that percentage of 48% times 98 for 984. And then you do the same thing. Let's see, for female Republicans, you take that column total of 975 times the row total, 936, divided by the grand total. That gives you the expected value up here. And then you do a similar sort of calculation to get the expected values here. You take the column total, 964, by the row total for the Democrats, 1,023, divided by the grand total. So that's all just sort of technical stuff. Don't want to get stuck on that. But you get the expected value for each of these cells. And when we're doing the chi-square test, there is one requirement that we have, and that's that every expected value has to be at least 5. Okay, so if you get an expected value less than 5, then you would have to go and do a different kind of test to answer the same question. And the
Right, let me
basic,
just mention that a lot of statistical tests require a minimum size. We call this the sample size. If you have very few cases, like you're only looking at a classroom of 30 kids or something, and it's very disproportionate. There's only an expected value of 3 or 4 in one of the cells. The statistics are just not very accurate, and you can't, they're just not going to give you an accurate result. Um, so, in this case, we've got almost 2,000, so we don't have a problem.
Yeah. So it's the basic idea behind the chi-square test is if you've got a big difference between observed and expected, uh, then probably something is going on here. The genders in this case are probably preferring different political parties. But if your observed and expected values are fairly close to one another, then that would mean in this case that the men and women are probably voting the same way, pretty much. And so gender doesn't really make a difference. I'll quickly spout out the actual formula. For each cell, you find the difference between observed and expected. You square to get rid of any negative values, and then you divide it by expected. It's sort of, if you look at it as a percentage of expected value for each cell, that kind of cuts it down to size, and you add up all those numbers for each of the 4 cells. And the result is supposed to be distributed according to a chi-square distribution, which sort of looks like this. It's not symmetrical. It kind of goes up, has a long tail going out. And like I said, if the difference between observed and expected is too large, then your calculation for chi-square winds up being, way over to the right in that tail section, and you get something significant. In the z-test for 2 proportions, well, anytime you hear a z being used, that implies there's a normal distribution involved, which is going to be your bell-shaped curve. And in doing this, let's see, for the z-test for 2 proportions, you usually have something like this. You might have the number of Republicans, 504, the number of women who vote Republican, I think that's 432. But then you deal with the column totals here. You look to see what percentage of this column total is 504, what percentage of this column total, 975, is 432. And you're asking the question usually, are those 2 percentages close to one another? You can also do a one-tail test, which I usually do, where for one reason or another, you think one of the percentages should be larger, and so it becomes is that larger percentage significantly bigger than the other one? There's a more complicated formula for computing your z value to show where the result falls along this normal distribution. But the normal distribution, it's that nice symmetrical bell curve. And if you're doing a one-tail test, then if your z value falls too far in one of those tails, then it becomes a significant result. There are a few caveats to keep in mind when you're doing the, let's see, the z-test for 2 proportions. One is that your variables are independent of one another. In this case, if you're looking at the number of men who voted, or percentage of men who voted Republican versus percentage of women who voted Republican, how a man votes should not affect how a woman votes. That's basically what we mean by independence. And another caveat is that none of the counts you have should be less than 5. Okay, some say less than 10. I usually go with less than 5. So they all have to be 5 or larger. Now, what if you don't have that condition being satisfied for using the z-test for two proportions? Or what if one of your expected values for a chi-square test is less than 5? Well, that happens sometimes. And when that happens, another test you can use is,
Christopher, before we go on, let me interrupt.
yeah,
Um, so the chi-square does not assume a normal distribution. The z-test does.
yeah.
So getting to Kai's question, if I'm doing this research and I have, these values, what are it looks like I can do a chi-square or a z-test. What, under normal situations, like which one should I do?
Uh, you can pretty much pick
You can pretty
as
much
long
what?
you can pretty much pick either one. Uh, it's, as long as those conditions are being satisfied, uh, you can pretty much pick either one. The way Z is computed, it will belong to a normal distribution. It's not like the data, we're not talking about the data being normally distributed or chi-squared distributed. It's just the results of the kind of computation you're doing will belong to either a normal distribution or a chi-square distribution. Uh, and but if you have an expected value which is too small or a cell count which is too small for a z-test for two proportions, then you can use Fisher's exact test. And Fisher's exact test doesn't really depend on any distributions at all. What Fisher's exact test is saying is if you're in a situation where these column totals and these row totals that we have in this diagram are fixed, how many ways can I fill in the cells to get, the result that I got? Or you look at how many different ways these cells can be filled in so that you get the same column totals and row totals. And then you look to see what is the exact probability of getting exactly what you have. And in
Let me just
Fisher's
clarify,
exact,
the Fisher's exact test does not assume any distribution of the results. And the
yeah,
chi-square assumes a chi distribution, and the z-test assumes a normal distribution.
yeah, for the calculations that it's doing.
Right.
And that uses those distributions to compute a probability. But in the Fisher's exact test, which is a good alternative when some of these other conditions aren't met for using either a chi-square or a z-test, uh, it's basically just counting up the total number of ways something can be done and versus the number of ways you can get what you've actually observed. And then it's computing an exact probability from that, which is why it's called Fisher's exact test. Uh, there are a few more tests you can do. In the past year, I've become aware that a lot of people, instead of a chi-square test, they're using what's called the g-test. And I can't tell you off the top of my head how that's defined, but basically, uh, if you're doing, in theory, if you're doing chi-square tests and if your sample sizes are getting larger and larger, the results that you get back for chi-square tests should get closer and closer to what you get back for a g-test. So in one sense, you can think of the results of a chi-square test approximate what the g-test is giving you back. And so a lot of statisticians seem to be liking that now because they see the chi-square as only an approximation of the g-test, and the g-test maybe being a little bit more accurate. The G test, it's something that can be done automatically in R. And then there are a few other tests. There's another uh, type of test that's, let's see, similar to the Fisher's exact test. And I don't remember the exact name of it. I think it begins with the B. It's something like the Bernard test, but I'd have to check and look that up. Uh, the Z test for two proportions, well, let me say this. The Fisher's exact test tends to be a little more conservative,
Right.
meaning the p-values are usually a little larger. Uh, the z-test for two proportions, it's maybe the least conservative of all those tests. It might give back smaller p-values. But, for what I do, I'm not real excited unless, everything's giving back, small p-values. If a z-test for
Yeah.
proportions gives back something like, 10 to p equal 10 to the minus seventh, but chi-square gives 10 to the minus six. I don't quibble about that. They're both
Yeah.
uh, me that something is really significant here. And, if the p values are small, with a few of them being, say z-test being slightly significant, but chi-square tests not being significant at all, or Fisher's exact not being significant, then, I'm not too excited about that result anyway. I don't, jump on that one result, which is just barely significant and say, okay, stop the presses. This is a big result. Now,
Yeah,
usually,
let me underscore a few points for me because this is really important. Is that the Fisher's exact test has fewer assumptions because it doesn't have an assumption about the distribution.
yeah,
So you may say, well, that's wonderful. Like, why, I'll just use Fisher's exact test because I don't know what the distribution is. So let me use that. But that's the good reason to use the Fisher's exact test. The bad reason, or an argument against it, is it has less what we call power. It has
yeah,
less ability. Power means the ability to find something that's there. So
yeah,
if women are voting different from men, can the statistical test detect that? And Fisher's exact test, we call it conservative, is what Christopher just said. Um, Another way of saying it is it has less power. In other words, if Fisher's exact test finds a big difference, you have a different, there's a difference
yeah,
because because it's not making any assumptions. The z-test is assuming the distribution is normal. If the distribution is not normal, then you're getting fake results, you might say. So what Christopher is saying is that if you ran all three of these, in reality, with a fairly large sample size, you're going to get similar values. Typically, a worse value means higher p-value with Fisher's exact test because it's more conservative.
mhm,
And what he's also saying is that if you get like p less than 0.001 or better, you've got something. So the only time people, I think one of the only times people get really picky about these differences is when they are trying to measure something so precisely. But in most social science research, we're just trying to see if there's something there, you know. And and if one gives p less than 0.001 and the other one says triple O one, you found something. So you should get somewhat similar results with all of these, typically not quite as good with the Fisher's exact test. So to answer Kai's question, it doesn't matter very much. If you want to be like really super careful, run all three. Like if you want to be like cover all your bases. Does that sound right, Christopher, what I just said?
yeah. And one paper I did for correlation, I did z-test for two proportions, chi-square test, g-test, and Fisher's exact test to show that all four of those tests would give back similar results. And let me sort of modify one thing you just said about power. The way I would say it is uh, the power of a test is your ability to detect a significant difference when significant differences actually exist.
Yes.
And a lot of the early statistical ventures into astrology, with the exception of Gauquelin, uh, but back in the 80s and maybe 70s, when people tried to do some basic statistics to show astrology works, a lot of their tests failed. And we now know that they failed because they lacked sufficient power. And there is a nice little freeware program a lot of people are using now called G Power. It's sort of G star power, and it's one thing you can download for free, and with a lot of basic statistical tests like chi-square or Fisher's exact or whatever, you can do a post hoc estimate of the power of your test to see if you didn't get a significant result, maybe you didn't have enough power. Another thing, well, two things we know today. One, astrological effects aren't all that strong, right? It's not like gravity. You know, if you jump out of a plane without a parachute, the effect of gravity is going to give you the same result each time. Uh, you know, astrological things, they're like, well, like if you think that Mars square moon is going to make you have an accident that day, well, people don't have accidents every single time there's a square between Mars and their moon. But if they have accidents more often when compared to people who don't have Mars square their moon, then that is telling you something. So, you know, the effects of most astrological variables they're kind of weak to moderate in effect, and I think that's a good thing because otherwise we wouldn't be able to use our free will to alter the situation, to make things work out better for us.
And
Uh,
consequently, things like the power of a test are extremely important. So if somebody says, if you're reading a paper and it says, "Oh, we found that Moon Square Mars correlates with accidents," there's all kinds of questions that raises, like, um, what is the p-value? There's something called effect size we can talk about. Um, and what is the power of the test? Because some people will use a test with greater power. For example, suppose that Jane does a z-test
mhm.
and Sally does a Fisher's exact test, and Jane's getting a little bit better results uh, because she's used a test that's more capable of finding something. So there's these issues when you do a test as to how good is the test at detecting the difference. You
Yeah,
can here's something that I've been bothered by in astrological research is the way you report the values for somebody who's not familiar with how to read research papers. You can make the results look better or worse depending on how you report them. So if you report a one-tailed test, your p-value is twice as good as if you do a two-tailed test, which you're allowed to do a one-tailed test, but when you read the research, it helps if you understand these things. Or if somebody's
yeah,
doing a z-test and another person is doing a Fisher's exact test, the Fisher's exact test typically doesn't give results quite as good as a z-test. So you might have the same result, and the only difference is what test was run, um, whether it was one-tailed or two-tailed, and then there's the big issue of how many people are in your sample size. The more people you have, the greater your power, the more able you are to find the difference. So all of
Exactly.
these things affect what's going on. It's not as simple as saying, oh, I got 0.01 p-value. How many people were there? What kind of test did you run? And, were there other possible biases, et cetera? All these things relate to how impressive the results are.
Yeah, and it's one of the things that has been learned over the years is that to be able to identify these significant results, we need lots of data, lots and lots of data, because with the kind of smaller sample sizes people worked with back in the 70s and 80s, the statistical power wasn't there. There was not enough power to detect a significant difference. When you have thousands of charts, that can really help bring things into a strong focus. And like I say, I usually wind up doing a one-tailed z-test for two proportions, but I think it's also important to explain why you're doing a one-tailed test instead of a two-tailed test. And in the let's see, the latest paper I've been working on is it has to do with people who are gay and people who commit suicide. And we know from data that people who are gay have much higher suicide rates as compared to people who aren't gay. And I found what looks like an astrological signature, which occurs significantly more often in people who are gay and in people who commit suicide. So it's really interesting, and I found it would replicate over two different distinct time periods. And by the way, when I see a p-value like 0.01, I'm really doubtful that something like that will replicate on a separate set of data. Usually have to have pretty small p-values in order to be able to get significant replication. But with that study I was doing on gay people and people who commit suicide, I had been using data from Astra Databank, using Rodden rating of B or better. But then I decided to test it on the data there rated X, which means usually that the birthday is correct, but not the time. The time's not known or it's not correct. But I was working with slower moving planets, so the birth time shouldn't be an issue. Well, I did my tests on the data with the Rodden ring of X, and none of it really came out significant or strongly significant. But when I looked at the power of each of my tests, they all had extremely low power, meaning that oftentimes there's a 75% chance I would make a type 2 error, meaning that I would fail to detect a significant result when there really was a significant difference in reality.
And I want to underscore this point for people that are not used to thinking about these things. The way we're thinking in research is that there is an objective reality out there. Like women vote a certain way, men vote a certain way. There's something there. What the statistical test does is try to detect that difference. And so, each test and the conditions of each test make the ability of the test to detect the difference, it varies depending
Yeah,
on how many people you're studying, what kind of test you're doing. So it's good to keep in mind that the statistical test is simply trying to determine if there's a difference. And that test, it makes a lot of assumptions and it's affected by various things, such as how many people, what we call the sample size. And like Christopher said, in cases like astrology, where typically it's not like gravity, it's um, the effect is not huge. You need a lot of data. The more data you have, the more you're able to detect it. I often give the example of height of people. Suppose the height of people in one country, the average height is 5'10", and another country is 5'8". Well, if I only get 20 people from each country, the people in one country are 2 inches taller, but I don't have enough data to detect that.
Mhm.
If I have 10,000 people from each country, I will be able to detect that there is a difference. So the more data you have, the more able you're able to detect these little differences, and that's the power of the test. The test is more able to find those differences.
Yeah, and another thing to keep in mind is there's always a question of whether the sample we have is truly accurately reflecting the population. And an example I think we can all relate to is every time there's a presidential election, as we get closer to election day, all these polls are done, and they don't always come out with the same results. Oftentimes they can be like, the spaghetti maps for hurricanes, where it looks like they're all over the place.
And
And
sometimes
so,
they're wrong. Like when the one election, the poll said that Trump would lose and he won the election.
yeah, but when you got big differences sometimes between these polls, then you know that they're not all accurately reflecting the population.
Yeah,
Um,
one thing that's interesting in sampling for politics um, is in this survey course I took in college, they pointed out that political surveys in the United States were much more reliable. They worked much better in the 50s, 60s, 70s, and 80s than they do now. Why? Because in the 60s and 70s, most people had a phone in the house, and you would randomly select phone numbers, and they would answer the phone and they would tell you who they're going to vote for. Now we have cell phones, they're all over the place. It's very confusing. It's hard to know, some people have multiple phones, kids have phones. So you no longer have the ability to sample the voting population to get a sample that represents the people who vote. It's much, much more difficult. And because of that, the surveys are not as good. We just don't have, I mean, you can go door to door, whatever, but it's much more difficult to get a sample that reflects the actual voters.
yeah, and there are also people who don't want to respond to surveys. I
Yeah.
get text messages from time to time saying, we're taking a survey, blah, 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 blah. And I usually don't respond because I'm always suspicious they're going to use identify me and use that information for something else. But if you have a lot of people who don't respond to a survey, well, maybe those people are going to vote differently from the people who do respond. So that could be a source of bias in the results. And all in all, I think it's rare for statistics to be able to prove anything beyond a shadow of a doubt. Uh, at best, I think we get more confidence in certain results and less confidence in other results. So it's really, as I say, a sticky wiki kind of endeavor.
Yeah, Christopher, I'm glad you mentioned that because in my way of thinking, the research is all about confidence levels. That's what it is. Like, did we increase our confidence in thinking that something works or doesn't work? It's just confidence levels. Because a lot of people when they hear like that I do research, they say, oh, you're trying to prove astrology. Like, oh my God. that's so foreign to the way that researchers think. We're just looking at confidence levels. Do we, are we getting a greater confidence in something?
Yeah. And it's, one of the questions that's always in my mind is, since I do a lot of research using the data that's available for free at Astro Databank, every time I do something, I always wonder in the back of my mind, uh, is the data that I'm looking at representative of the population? I've got a lot of data here, but still possible that, what I see at Astro Databank may not be quite the way it is in the overall population of the country or the world.
Yeah, and how you define the population becomes interesting. Like a lot of, if you're doing research on marriage, well, you're doing research on adults. I mean,
Mhm.
intuitively, we know that, but in research methods, we try to define everything clearly. Like what it is, the population means who am I trying to understand? So if you're doing marriage, in general, you're trying to understand adults. Has nothing to do with children. And so that's your population. Now, people may get married for different reasons at different times, different places, different, even neighborhoods. Um, so who did you, who are you studying um, in your research, and who is that likely to generalize to? Is something to keep in mind.
Yeah, and population can often be in the eye of the beholder. One person, for one researcher, the population they're interested in might be only the people who live in Texas. For another researcher, it could be the whole country, everyone in the United States. And for a third researcher, it might be the entire world. Uh,
Yeah.
let's see. I see Linda's hand is up. Let's see. Did you have something to say, Linda?
Yes, I was wanting to know, it's kind of like what you just talked about. Um when you talk about the expected population for like a chi test or something like that,
Mhm.
is that affected by the number of like men and women in the population? I mean, the general population has more women than men, but what about the registered voters? And does that have, and do those kinds of things affect the expected value?
Well, for the chi-square test, your expected values are determined just from the data you've collected.
Okay.
Yeah. So if you, let's say you've collected data from a certain number of women, and you've got data for men, and you could go ahead and do the chi-square test, and you can find your expected values. But if you decide for some reason that you really need more women in your sample before you do your test, well, you go out, you get more women in your sample,
Mhm.
and those new numbers are going to change your expected values.
I got you.
Yeah, and in fact, one solution to if you have the time and opportunity to do so, if you're intending on doing a chi-square test, but one of your expected values comes out less than 5, which means that the results won't be necessarily valid. Uh, you can either do the Fisher's exact test, which doesn't have that requirement, or you can go out and just try and get more data. If you get more data, your expected values will tend to go up.
Mm-hmm.
And typically, research is not perfect. So typically, the sample is not a perfect reflection of the population. So you just deal with the reality and try to do the best you can. Because no matter how you collect the data, like if you went out in front of a grocery store to collect the data, well, certain kind of people go to grocery stores. And certain income range, certain gender balance, certain what, a whole bunch of things. So, what you're really analyzing is the voting patterns of people that go to a grocery store on whatever time of day, whatever town you're in. So, you do the best you can to get a sample that represents whatever population you're interested in. But research is all about just doing the best you can. It's a pragmatic exercise.
Yeah,
It's not an idealistic exercise. You're just trying to get better information than we currently have. If it's better
yeah,
than what we have, it's a success.
yeah,
And often we use this word incremental. It may be an incremental improvement. We now have slightly greater confidence about whatever it is we're studying, and that's what it's all about. Most research is just a little bit more confidence about something.
yeah. And I would say, Santino, I think you and I are probably equally concerned about things like bias, type 1 errors, and type
Yeah.
2 errors. But we're different statisticians. We may go about handling those concerns differently. To reduce the likelihood of a type 1 error, a lot of statisticians will do what's called a Bonferroni correction, which means that they'll lower the threshold of significance for the p-value. Um, I prefer to handle type 1 errors by showing that the results replicate on different sets of data, which, and, that's just a preference I have. We can be concerned about the same problems that arise in statistics, but different statisticians and data analysts might go about um, finding solutions to those problems differently.
Yeah, it's a very good point. So, the research scientists agree about the principles. There's very little disagreement about the principles and the concepts. There's often a lot of disagreement about what to do about it. In other words,
Yeah,
doing a Bonferroni correction or, replicating across different time periods, everybody agrees they both work. But which one are you going to do? And how important is it? Among astrology researchers, I'm known, as Christopher once said, to be a real stickler. Like I'll get all bent out of shape about something that I see as a bias that I feel like is really decreasing my confidence massively because not everything is clearly measurable, you
yeah,
and so people have different styles. They'll emphasize different techniques, and the great thing that I think Christopher and I agree about is the more variety, the better. It's better if we don't do things the same way because it's what we call in physics triangulating the problem. If somebody is very careful about Bonferroni corrections and someone else is very careful about replicating across different time periods, well, if you have one researcher doing one and another researcher doing another, you're covering all the bases. Because if there's a real effect, it's really there and it's going to survive any kind of um, testing of problems.
yeah. I think it's always good to look at data from multiple angles. Uh, some people I think want to look at it through just one lens, and maybe one test out of 10 possible tests gives the significant result that they want, and they ignore all the others. But if the others are showing it's not significant, well, that reduces my confidence in things. And another thing I think to always keep in mind is that the results of statistical tests, like sometimes people get like p equal 0.01 and they think, that result is written in stone. What I found could happen only one time out of 100. So therefore it's significant. But data is something which is always changing, always fluctuating. Different tests will give back different p-values. And if we sample the data at a later date and do the same test, we usually get back something different. So, none of this is completely written in stone. It's always fluctuating, but when we get similar results over and over again, that gives us more confidence that this is something fairly reliable.
And the same
Uh,
problem happens in a lot of physics as well. There's the famous 5 sigma. So in a lot of physics research, when you reach 5 sigma, which is 5 standard deviations, and about one in I don't know how many millions, whatever, um, then they become extremely confident. I read in one chapter in a book I read recently about findings in physics that were later removed, where they said, we found this, and then a few years later said, oh, we didn't find it. So you can reach 5 sigma, these tremendous things, and it could still be there was some kind of hidden bias or a little flaw in the procedure that was actually involved. So even in measuring material things, which is much more precise than measuring people, it's a slow and gradual process. But those cases of having huge confidence in physics and then reversing the decision, it's extremely rare. But it does happen. So it's all a gradual process of refining, 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 refining.
yeah, and we see this happening a lot in medical research,
Oh yeah, wow.
where you know, based on the evidence at the time, doctors may say, take this amount of aspirin every day or this amount of that every day. And then 10 years later, those recommendations get revised as a result of new research that's been done. And that happens quite a bit, I think, in medicine.
Yeah, and there is corruption in medical research. It is documented in peer-reviewed journals, so it's not just some fringe thinking. So, research depends on the integrity of the researchers, and
Mhm.
we're humans, and researchers are humans. Everybody's human, and people do sometimes cheat or they bias results, et cetera. So, there's a lot of things that go into research, but ultimately, if somebody says they did something, hopefully they did actually do it. And that's why the peer review is so important. Vincent.
That corruption, do you have an idea of its order of importance? I've got my own an idea, and I can tell you after, but I just want to hear you.
It's hard to
If
hear
you
you,
go in the
Vincent.
best journals, Nature, Lancet, British Medical Journal, and New England Journal, which would be the level of corruption? You have an idea?
So you're saying that, what's your question, Vincent? You're
You
asking
spoke about
how much
there's
corruption is there in,
What would be the amount in percentage of what is published in medical research? What would be the level of corruption?
I don't know. I mean, I'd have to, in one of the tutorial videos I made on research methods, I gave the journal article, I think 2 or 3 articles on it. And I don't remember if they specified percent of
Okay.
corruption.
Someone else would have an idea?
Uh, I,
Christopher?
I'm not quite sure about this, but every now and then I will read something about a replication crisis in research.
Oh, that's something else. When I
Yeah,
speak
that's
of
something
Okay.
else.
yeah,
And
you're
that's
right.
Okay.
that's
When
a
I speak
problem
of
too.
cheating, I speak of conscious cheating, not the one
Oh,
that you're evoking. Yeah. Okay,
I
that
would hope that
level,
that's
that level
a
is
small problem.
that level is it's incredible, but there's some. Okay, let's go with the proof. The four, how do you say that in English? The rédacteur en chef, the like
For journals?
the boss who editor, like Robert Curry with correlation.
Yeah.
What's the name of that in English? Editor?
Yeah, editor. Yeah.
Okay,
Editor.
3 retired and 1 still there in Lancet, whose name is Horton. One is a lady named Angel, and I don't remember the 2 others, but from the 4 main journal I cited, they all independently came to 50%.
Oh my God. Whew.
50% are cheating?
Yes, 50% of shit, of
Hmm.
nonsense. They admit that when they worked, they were publishing 50% of untrue, false research.
Yeah, one of the problems is that a lot of the funding comes from private companies.
Yes,
This is a
exactly.
huge problem because the private companies, pharmaceutical companies, and other companies, they fund the research, and of
Mhm.
course they want some particular
Yes.
result. So the problem of ethics of people cheating is a big problem, and sometimes people cheat in order, they're professors. You have the saying "publish or perish," and if you get positive results, you're more likely to get published. So there's
There were
there
yeah,
are
you're
ethical
right, but
problems.
this ego about perish or publish, but the main reason is the corruption of pharmaceutics, which is the biggest by far lobby in the world.
What is the
Right.
lobby? What did you say, Vincent?
Big pharma.
A big pharma, yeah.
They're
Yeah.
extremely corrupted, but it's documented. You can even find this on Wikipedia.
Yeah, so one of the problems with research methods is there's no way to force people to be ethical. People can lie. They can falsify data, and
They won't go in prison.
it can go undetected for long periods of time, et cetera. So, yeah.
Yes.
Now, fortunately, in astrology, nobody is paying us a lot of money to get certain results. So we tend to be poor and honest. I'm joking around a little bit. Um,
Yeah. Another problem in evidence-based science arises from the fact that uh, most of us are not able to know everything about everything. So
Mhm.
let's use evidence-based medicine as an example. If you're using evidence-based medicine, you're uh, basing your practice on results which have been verified by statistics, right? Okay. Well, when I go to see my doctor, I often ask, you know, which of us is really in charge here? You're the doctor. You know a lot about medicine, and you say you're doing evidence-based medicine, but that means your results are based on statistics. I'm the statistician. I don't know a lot about medicine, but I know a fair amount about statistics. So, who's the person in charge here? The medical professional or the statistician?
yeah.
And sometimes in education and other disciplines, a lot of data will be collected, and then there will be the analysis will be farmed out to companies which make their business by just doing data analysis for people. And in those instances where I've seen their results, I've often found a lot of typos, mistakes in their work, and I'm just very suspicious about them because they have uh, a stake in getting significant results so that they can get more jobs doing statistical analysis for people. There's all sorts of ways in which research can go wrong.
Yeah. Yeah. And that's where the idea of evidence-based, which really started developing in the 1980s. It's not that old. The ideas started being proposed around the 70s. By the 80s, it was getting implemented, started with medicine, moved into other fields like psychology, is we don't know what to do when somebody comes in with an illness. Nobody knows what to do. So we'll just use the best information we have. Even if it's not very good, it's still the best we have.
Mm-hmm.
And this is one of the things that I'm very keen about with astrology is I do not have huge confidence in any astrological research, but I have more confidence in some of the research than I do in what astrologers currently do. So in other words, it's the best evidence available. Even if it's not fantastic, it's whatever it gives the best evidence.
Mm-hmm.
I don't
That's
understand. Would you repeat slowly because I missed what your point.
the point of evidence-based. So what happened?
You said you don't have confidence in research. Then I missed what you meant.
Let me give an explain it with an example. Let's say doctors don't know what to do when somebody has pneumonia, or some other disease. They really don't know. They're not confident about what to do. Um, so the principle of an evidence-based practice is that you use whatever gives the greatest confidence. And they have this pyramid of a hierarchy of what gives greater confidence. And you just take all the data, all the information, you look at it in this pyramid, and you decide what level of confidence you have. So even if you have very low confidence on what to do when somebody has pneumonia, it's still your best guess. Because sometimes we just don't know. But the idea in evidence-based practice is you have to use the best available information. Doesn't mean it's good. It just means it's better than anything else.
So if you relate to astrology, what do you mean?
Well, in astrology, if somebody has, like Christopher's collected data on people that are gay, suicides, etc., and he's able to discern certain things in that data, that gives us a good level of confidence, better than anecdotal evidence. According to the pyramid used in psychology and medicine, data-driven evidence is higher on the pyramid than individual experience. So
Sure.
using an evidence-based practice, we should be using Christopher's findings on this. Practicing astrologers should use it if we were an evidence-based practice because we have greater confidence. Now, I may be extremely doubtful about Christopher's findings, but I'm less doubtful about it according to the evidence-based pyramid than I am what some astrologer tells me, because a majority of people believing something according to modern research methods does not give high confidence. Now, you don't have to agree with modern research methods, but if you do, you just follow. It's like a sport. Here's the rules. You follow the rules. It's all about confidence levels.
Yeah, and that's a good point. There are, some kinds of evidence give us more confidence about things than other kinds of evidence. A lot of scientists and other disciplines, they will look at astrology and they will use the term anecdotal evidence in a very dismissive way. And sometimes I will too, but over the centuries, even though this is sort of the base level of evidence, a lot of what others are calling anecdotal evidence, I will, in some instances, say, no, they're actually very careful case studies. Not unlike the ones that were done in cultural anthropology in the 20th century, or not unlike the ones that are done in mathematics education these days. So even though it's at the bottom of the pyramid, if there are good, thorough case studies that have been done with a lot of different people, that can still be a good source of evidence. It's better than nothing.
Right. You have to start somewhere, and almost all research starts with personal observations.
Yeah, and some of those observations are going to turn out to be statistically significant when you take them up to the next level.
Yeah, and people can get, their inspiration from anything. People can have a dream, they can have a psychic experience, they could be channeling from angels, whatever, all of that's fine. It doesn't really matter that much. What matters is, did you then go to the next step to test it?
Mm-hmm.
So if you have a lot of faith that astrologers over the thousands of years were not delusional or whatever, and they're actually doing something like case studies, then your guess is that that's what you're going to build from. You have to build from, you got to start somewhere.
Yeah.
Yeah. I always love the saying by Richard Feynman, the great physicist, that science is making a guess and testing your guess. And he said the difference between me and most of the population and other physicists and most population is the population, most people do not actually test their ideas very carefully. It's the careful testing of it. So yeah, anecdotal evidence is usually where things start, or
Yeah.
personal experience, whatever you want to call it.
Yeah, it's well, just to give an example, a lot of people, when Mercury goes retrograde, the common belief is that, all sorts of communications are going to go haywire. Your cell phone or your internet is going to break down, things like that. And so it's very easy if you get an internet outage to say, oh, well, of course, Mercury is retrograde. To me, that is, I don't have a lot of confidence in a lot of the statements people make about Mercury retrograde unless I've seen some really good studies done on that. On the other hand, if someone like
there's one, Christopher. You don't know about it?
No, I don't. You'll have to send it to me.
No, not me. Renee O'Shop has done it.
Oh, is she the French
she
woman?
examined all the prompts, I think, on the internet to Amazon. I don't remember, a closed field.
Mm-hmm.
And there's a lot more, significantly more typos, errors, syntactic errors in the prompts when Mercury is retrograde. To my big surprise. To my big surprise.
Who did that research?
You were there when she presented it. You were there in Florida.
What's her name again?
Renee O'Shop.
Renee, yeah, O'Shop, yeah.
She's a mathematician.
Yeah.
Astrologer. You were there when she presented it.
Oh, yeah.
In Florida.
Chris?
It's
if you recall, she also found that when Mars and Venus are retrograde, grammatical and spelling errors are at a minimum.
Chris? I missed what you said.
She found when Venus and Mars are retrograde, spelling errors and grammatical errors are at a minimum.
Yeah.
Okay. I don't remember that.
I do.
Yeah. These are studies which take that to the next level. beyond just hearsay or anecdotal evidence. So when there's a statistical study to back it up, that is when I have more confidence. But just in terms of that base level for research, I have much more confidence in the historical research, for instance, that Rick Tarnas has done, than people who just go around and say, "Oh, this will happen because Mercury is retrograde," if they don't have statistical results to back it up. So what I'm trying to say is that at that base level, some of the case studies that have been done are much more extensive and much more thorough than others. And when that's the case, then I have more confidence in the results. But we always want to try and take it to the next level.
Chris,
Yeah.
Chris,
Yes.
could it be that when we have retrograde is because we collectively induce it? Everybody talk about it,
Yeah.
and it becomes retrograde because there's a collection of the energy that, and it just happened that way. There's a
It's
presence of everybody just saying it so much that it retrogrades because there's a huge amount of people are saying it at one time, and it becomes a retrograde
Mm-hmm.
based
maybe
on the fact
I don't think
based on
that's
the
the kind of thing we can detect those with statistics.
yeah, and well, I was just saying that if it
Yeah.
retrogrades, that's how you were pointing out, is that everybody's saying it's going to retrograde or saying it. There's a collection. There's this huge energy by everybody saying the same thing, and it becomes that way. Just like
Oh,
just like the scientists looking at the observation experiment,
I think it's a good
the
point.
golden shape.
It could be a self-fulfilling prophecy.
Yeah,
or
and
or
and also when you raise that Mars and Uranus uh, conjunct or square and having an accident, and you make that comparison with gravity. Every time you drop off, you're gonna fall, and that's the same thing happening. But one of the things is that we're not considering that there are many other things that are involved in Mars conjunction or square to make it an accident. And if it happens, if it comes back the same way, are we considering all the things that are involved in the, the square? Is it the square? Is it a full square? Is it orbed by so many orbs?
Mhm.
Or is it exacting? All these stuff. Yeah, yeah. That creates the difference. There's many things that we are not aware of in astral world, and because of that, it creates a lot of errors and a lot of misconceived things. So it's much more difficult thing to kind of test astral because there's so much things that we common astral people don't know of.
Yeah, a couple of things I've been thinking about lately are, in science and in statistics and science in general, we often try and isolate variables in order to test their effect. But as you're pointing out, uh, we can't, I'm not sure we can completely isolate anything from anything else. As you're saying, there could be a lot of other variables involved, which are also influencing things. And it's hard to discover those and to know exactly what the impact of these other variables are. It's a difficult task. And on a philosophical level, I've been wondering lately, we often need variables to be independent of one another to do this or that statistical test. But in reality, I sometimes wonder how independent anything can be from anything else. At the same time, we're trying to say this is independent of this. We also may talk about how everything's connected through quantum entanglement or the butterfly effect or fractal self-similarity or very complex webs of causality. It's really difficult to know how independent some things are from other things, or what other variables might be important that we're just not aware of yet.
Yeah, I often hope that the Vedic astrologers are wrong about their theory of Nietzsche Banga. Nietzsche Banga is where you can have several indicators say that a person will be wealthy, but it's destroyed by another variable. Like if something's in a particular house or whatever, it will destroy the power of something else. And so you don't have this nice linear additive thing. And getting to Desdale's point, like if some of these variables destroy the power, and this is a prevalent idea in Vedic astrology, Nietzsche Banga, the destroying of something, in which case, if you're not taking account of those variables, in modern research methods, we say very strong interaction effects, like really strong. So yeah, I mean, these are things we don't know about. Another thing related to what Desdale was saying about people thinking about something, I know an astrologer who used to travel 3 or 4 times a year, and she preferred to travel when Mercury was retrograde, because she said that when she flies, when Mercury's retrograde, there are fewer people flying and there's less happening. And consequently, there's fewer delays. And the theory is because so many people are aware of Mercury retrograde, they're not flying. And that effect is now making it better to fly when Mercury's retrograde. I mean, I don't know if that's true, but that's what she did. She would try to fly when Mercury's retrograde. And, the flights like were almost never full, etc., from her anecdotal personal experience. I thought that was interesting. Okay. So is Kai still here? Kai, you are here. So I think we answered your question.
Oh yeah. Oh yeah.
I think we answered about an hour ago. That you can do both. Do the chi-square and the z-test. And if you want to go all out, run Fisher's exact test as well. You should get similar results.
Yeah, and if you use R, those can all be done pretty easily in R. I'm not a great coder or programmer, but I can easily get them done in R. And with chi-square and let's see, z-test for two proportions, all of that's built into my TI-84 calculator, and most scientific calculators can do those real easily now. So we're really living in a good time for statistics because we have so much data available now. There are a lot of big, large databases. There's a lot of software to handle the what used to be rather tedious number crunching you had to do by hand, and we have very powerful scientific calculators. Our scientific calculator is more powerful than the computers that I think were on the Apollo mission when people went to the moon. So in that sense, it's really sort of a great time to do statistics.
And Vincent, I think both Vincent and Kai, I think both of you're able to do a lot of statistical analysis in Excel, right, Vincent?
Yeah.
Yeah,
All of these tests are built into Excel functions too. You
right.
just plug in the function and plug in the variables.
Yeah. So an easy way to do it as well.
Yeah,
Uh, Can I say something?
Yeah.
sure.
Yes. We what I'm concerned about is the end result of our tests. Whatever we are testing, we need to have it available to everyone and anybody. When we finish with our tests, we're able to say, well, this is the case. Uh, we just don't want to have it where it starts, finish, or in the middle. Most of the stuff that we talk about, is there an endpoint to it? Is there a results to it where it's usable, so we can take it and use it in our practice? That's my concern. If we're going to do all the tests from all, we have many people here, and it based on the time when I'm on this platform, I I don't see anybody come up with a endpoint results to where it's usable. That's my concern. We talk about it. We should have something where we can do about it.
Yeah, that's a good point. The system of astrology, I use vibrational astrology. We do take the results from our research, and they do form the basis of how we interpret the charts. Down to the meanings of the planets and the aspects and so on. And we have, dozens of different research projects at varying levels of sophistication. Um, but in the vibrational astrology system, it is data driven. Like the things we learned in the bipolar disorder, the eating disorders, the athlete research, the musician research, where we find indicators of those things, and we develop principles of why that's working. So it is influencing how, what we practice and what we do with our clients and everything else. I'm not sure about other systems of astrology, how much the research is influencing what the astrologers actually do.
Yeah.
I,
Let me
I
give
go back.
my
I, I go back to what Chris says, because he makes a very powerful comparison of gravity and just the things that we do. I mean, simply, you put something out, it's going to fall. But whereas it's in our practice, where we try to gain the same thing in the same spot, the same area, the same prevailing winds. These are is like I'm seeing where with the tests that we use or the apparatus that we use for evidence base, it appears that we need another apparatus involved. I know those apparatus are tuned from other industries or other sectors of society, but here we're talking about astrology. Some of these things that are testable in those areas, we tend to be a lot more involved in the area of astrology, and I have the tendency to think that we need more to validate and evidence what we got going on in astrology world.
Yeah.
It appears that way because by itself, and we form a lot on just on the simple things in evidence base, because we got to talk about PVA, we to talk about this not coming at the right time, and all the other influences and the biases involved, and all these stuff. When we have those as base, it appears that we need to expand more, because astrology has been there before any other industry, any other discipline. So I think that going to need something more added to our apparatus to bring results in.
Yeah. Let me give my take on this. With all the research that I and Santino and Vincent and others are doing, I like to think we're trying to complete this grand painting that shows how and what works in astrology. At this point, every time we get a significant result, it's like adding just one little dot to that painting. And if other people get similar results, then that dot stays there. Sometimes no one gets the result you got, and you got to go back and erase that dot. But with every little statistical test, scientific test that we're doing, we're gradually just filling in more and more dots in this picture. Now, the end goal would be to arrive at the point that you want it to be at, where all of this research directly relates to the practice of astrology. And so all of these results wind up having a very important influence on how we practice astrology in the field. But at this stage of the game, that's not what I'm focusing on. I'm simply trying to show that astrological effects exist, whether the regular astrologer can incorporate those into their practice or not. I want to get us to the point where there is a preponderance of evidence showing that astrological effects exist, and that there's so much evidence that people in other scientific disciplines will then have to start looking at astrology seriously. So that's my immediate goal, getting to the point where we have lots of results which apply to the practice of astrology. That may come along later, but we may get some results sooner rather than later. If we have enough data, enough things to look at, for instance, at some point in the next few years, we might be able to make very good recommendations about which house systems work best and which ones don't work so well. And that would be something that everyday astrologers could apply to their own practice of astrology as counselors for other people.
So it's dot by dot. It's going to be a long process, I think.
It'll take a while, but quantum physics wasn't developed in a day.
Yeah.
There's a lot of math that had to be. It's almost like you have the same thing in mathematics. Typically, what happens is mathematicians they discover something just for the heck of it, just for the fun of it. They don't have any practical applications in mind, but 50 years later, a physicist or an engineer may find a very practical, real-world application for what the mathematician discovered. So it takes some time.
Okay, so we're at our hour and a half. A lot of people came in. Thank you all for coming. Does anybody have, as usual, a lot of you are listening. And does anybody have anything they want to mention or question or bring up? I like to make everyone feel welcome to speak up and no? Okay. All right. I haven't looked at the chat. There may be some interesting things in there. Okay, so is it a wrap? Well, let me check the chat out. Let's see. We have anything here? Um, yeah, some good comments.
Yeah. I see a comment from Blake that Astro Databank would be underrepresented with regular people who don't become famous.
Yeah.
That could be the case. That's always in the back of my mind, that with everything I find, I can show that it's a pattern in Astro Databank, which is perhaps extremely unlikely to have occurred by chance. But I always know in the back of my mind that there's always this possibility that Astro Databank may not reflect the entire population. And what is maybe more likely is there may be a lot of things at Astro Databank, a lot of patterns there, which do reflect the larger population, but there may be some things which don't. And that's why we need, more data, more databases, things we can replicate results on.
There you go, Chris. One dot at a time.
Yeah,
Got it.
but
Dot
it's
at a time.
Donald
Yeah.
Rumsfeld. He used to be, I think, America's Secretary of Defense. Not necessarily my favorite political figure, but he once said, we go to war with not with the army we want, but with the army we have. And so I've always said we do data analysis not with the data we want, but the data we have. And we just do the best we can with that.
Okay, good. And another comment I saw, Starlene mentioned the new website for Cosmobiology Institute. So if you go to cosmobiologyinstitute.org, you'll see the updated website that Starlene made. And on the opening page is the link to the information about the conference, April 24 to 26, next year in Nashville, Tennessee. In the next few weeks, we're going to have selected the speakers and the topics. If any of you would like to speak, like I see Bill is here, Bill Meridian. I think I haven't mentioned it to Bill before, and there's a few other people I haven't mentioned it to. Let us know right away because if you think you might want to go and you have some research, the theme of the conference is what have we found? What have we discovered? What is the research that's given us the highest confidence that there's actually a measurable effect in astrology, and what does that imply for astrologers? Are any of these findings strong enough to suggest that practicing astrologers should incorporate what's been learned from the research? And I think the answer is yes, and that's what we want to show at the conference. So that's the theme, Cosmic Discovery Conference. Okay. Anything else? Are we all good? All right. Thank you for participating and being a part. And I always encourage everyone to speak up and share. Okay. I think that's it. Thank you, Christopher, for covering all of that, and thanks to all of you. And thank you, Kai, for the question. It kept us busy for the whole evening. Okay. All right. Take care. God bless. Namaste.